back to my YouTube channel. So if you've been following my tutorial for a while, one thing you're going to notice is that for about a week I have actually been off. So I've been very inconsistent with posting videos. So and this is actually because for a week now I've been juggling between a couple of tasks, which has actually been taking my time. But well, I'm back and I'm happy to be here. So in this tutorial, we are going to be talking about exploratory data analysis. Yes. So I'm going to be showing you the types of exploratory data analysis. I'm going to be teaching you how to perform an in-depth exploratory data analysis. And I'm also going to be showing you how to tell a story using your visual. And also, I will be showing you how to give business recommendations using your visual. So if you've actually been looking at understanding what exploratory data analysis truly is, this tutorial is for you. And aside from that, we are also going to be performing an in-depth data cleaning using Python before we actually go into performing our exploratory data analysis, where we are going to be seeing how to uncover seasonalities and patterns using our data. I know you're very excited to hop in. Well, I am excited too. But before we hop in, don't forget to hit the subscribe button, like, and share. Thank you so much for watching. Exploratory data analysis, also known as EDA for short. What is exploratory data analysis? Exploratory data analysis, generally called EDA, this is a process of understanding the structure, quality, and patterns of your data before applying models or drawing conclusions. Doing exploratory data analysis, you use graphs and images to uncover trends, see seasonalities, and then make conclusions on your analysis. So basically, when you're doing an EDA, you're just trying to get a better understanding of the structure, quality of your data, and you're also trying to understand patterns and seasonalities in your data. What is the purpose of exploratory data analysis? According to John Tukey, EDA is the detective work that precedes modeling. Now, when we are talking about EDA, which is exploratory data analysis, it's just like doing a detective work, trying to understand the data, trying to understand patterns, trying to know what is happening in the structure of the data, trying to uncover seasonalities, and trying to uncover patterns in the data. Now, EDA precedes modeling. Before you go ahead to actually build your model, you actually have to do your EDA. Now, what is the purpose of EDA? Number one, we do EDA to discover hidden patterns. When we are talking about hidden patterns, we are talking about we want to know which product has the highest sales, which product or which category has the lowest sales. Now, when you do EDA, you'll be able to uncover hidden patterns. Number two, we perform EDA to dictate anomalies or outliers. As we all know, outliers are extreme values. Number three, we perform EDA to test assumptions. We perform EDA to validate data quality, and we also perform EDA to generate hypotheses for further analysis. So why do EDA really matter? Without EDA, we risk wrong insight, misleading visualizations, and broken models. But when we perform EDA, we will have a cleaner data, deeper understanding of relationships, a better model, clear and actionable business insights that will actually help managers to make strategic decisions. Now, let's look at the core pillars of EDA. Now, by core pillars, we simply mean steps, core steps involved in EDA. Now, we talk about before we perform the EDA, we have to collect our data, data collection and understanding or knowing what data represents. We have to perform our data cleaning, like handling our missing values, duplicates, and errors. Descriptive statistics, summarizing our data numerically. Data visualization, seeing the data through plots and charts. Feature relationships, which involves correlations and pattern across variables. Then we have to do our insight generation, of course, where we use storytelling through findings. Now let's look at the types of EDA. We have three types of EDA. The number one is a unified exploratory data analysis. Number two is a bivariant EDA. And the third is a multivariant EDA. Now let's talk about the univariate analysis. Univariate analysis involves analyzing a single variable, one column in the dataset. The main goal of univariate analysis is to understand its distributions, central tendency, and spread. So when we are performing a univariate EDA, the main goal we have is actually to understand the distribution of one column, to understand the central tendency of one column, and the spread of one column. Now, when you're doing your univariate EDA, you're trying to answer the questions: what does this variable look like on its own? When do I use this variable? To understand the range, average, and shape of that particular column, to check for outliers, skewness, and data entry errors as a first step before comparing variables. Now, let's look at this diagram to get an understanding of univariate EDA. Now, the types of variable and methods we can actually use when performing EDA, univariate EDA. Now, let's say we have a variable, let's say we have a numerical column where we have the age, salary, and sales. Now, we can actually use techniques like mean, median, mode, variance, standard deviation, range, histogram, and box plot. Now we can, for example, we can decide to analyze the sales column to see the most common sales range. We can also decide to analyze the product column to actually see the different products owned by a particular company. Now that is under categorical though. Now, when we are working with categorical data, we may be using columns like gender, region, and product category. Now, what are the techniques we can use when working with a categorical data? We can actually use a frequency table, bar charts, pie charts, and count plots. Now, for example, we can actually decide to count how many customers belong to each region by variant EDA. As the word implies, bivariant means two. Bi means two. Now, when we talk about bivariant analysis, we are actually trying to check the relationship that exists between two variables. It could be between a numerical and numerical variable. It could be between a numerical and a categorical variable, or it could be between two categorical variables. Now, when we are performing our bivariant EDA, we are trying to answer, is there a relationship or pattern between these two variables? Now, what is the goals of performing a bivariant EDA? The goals of performing a bivariant EDA may include one, trying to understand the correlations or associations between two variables. We are trying to detect trends or dependencies between two features. We are trying to identify potential predictors and target relationships. Now, let's take a look at this for an example of bivariant EDA. Now, we are going to be looking at the common techniques and variable types. Now, let's say we are trying to see the relationship existing between numerical versus numerical columns. Now, the methods we can actually use is scatter plots. Knowing the type of graph or the type of visual to use in when performing your EDA is very, very important. So after this tutorial, I'm going to be creating another tutorial where we can actually talk about suitable graphs or suitable visuals for each type of column. Now, you actually use your scatter plot when you are comparing two numerical values. Now we can also try to see the correlation coefficient, where we can use the Spearman ranking or the Pearson. And we can also make use of a line chart. Let's say, for example, we are trying to compare sales versus advertising spend to check if higher ads lead to higher sales. Categorical versus numerical. With this type of data, we can actually use a box plot, a Rowling plot, a bar chart, or a grouped summary, where we actually create a grouped summary in a table form. Now, example, we can actually have gender versus income, where gender is categorical data and income is the numerical data. Now, we can simply try to check if one gender has a higher average income. Like we can simply try to know, does female have a higher average income compared to male? Now, categorical versus categorical. We can actually use methods like cut tab, contingency table, heat map, clustered bar charts for this. Now, let's say we want to compare region versus product category. Here, we can simply try to find which product sells best in each region. Multivariate EDA. As the name implies, it involves more than two columns. So when we are working on a multivariate EDA, we are working with more than two columns. So we are going to be working with three or more variables simultaneously. Now, it is used when your data set has complex interactions that can't be explained by pairs of variables alone. When you're performing your multivariate EDA, we are trying to answer questions like, how do multiple factors together influence an outcome? Now, the goal of performing a multivariate EDA could include we trying to understand how several features jointly affect the target variable. We trying to detect interaction effects between predictors. We trying to simplify data using dimensionality reduction techniques. Now let's look at the examples of multivariate EDA and the common techniques used. Now when we are talking about multivariate EDA, we look at method or techniques like multi-regression, ANOVA, and MANOVA. Now, statistical, like I mentioned, we are talking about multi-regression, ANOVA, and MANOVA. Example, we are trying to predict sales based on price, advertising, and season. Visualization. For multivariate analysis, we can make use of pie plots, 3D scatter plots, a heat map, or a cluster map. For example, we can use those visuals to show how age, income, and spending score vary together. Dimensionality reduction. When performing dimensionality reduction, we can use method like PCA, which is also called our principal component analysis. For example, let's say we are trying to reduce 20 variables into two or three main components. Clustering. Now, here we are talking about methods like k-means clustering and hierarchical clustering. Now, for example, we can say we are trying to group customers by combined features. For example, age, income, and spending. Now, what are the key takeaways? Number one, you need to understand that EDA is the foundation of all analysis. So it is also very important to know that EDA is not about predicting. EDA is about understanding. So when you're performing your EDA, you're not trying to predict. You're just trying to understand your data structure. Now, visualization plus statistics equal powerful insights. Always link data patterns to real world meaning. Now, in the second part of this tutorial, we are going to be seeing how we can actually link data patterns to real world meaning. Now, one thing you need to understand when it comes to EDA types is univariate analysis is just trying to describe a particular column. For example, trying to describe the sales column or trying to describe the consumer column. Bivariate analysis is all about relationship, trying to see how two columns relate. Why multivariate analysis is all about interaction, trying to see how three or more columns interact with each other. Welcome to the practical phase. In the hands-on session, we will take a raw data set. Now we are going to be working with a very messy data set. So we are going to be performing our data cleaning. And please, we are going to be working with Python. Then we are going to be performing our EDA, and we are going to be writing insights from data and write business recommendations. So you will see how we can actually perform our univariate EDA, our bivariate EDA, and our multivariate EDA. And you're also going to see how we can actually write insights from data and how we can write business recommendations. See you in phase two. So I already have my Jupyter notebook open. The first thing we can do is let's just go ahead and let's rename this. So the first thing we can do is let's go ahead to rename this and let's call this EDA tutorial. Okay, so we have successfully renamed down to the EDA tutorial. Now, the next thing we have to do is, so we are going to be taking this step by step, and I'm going to be making the steps self-explanatory as possible. So the first thing we are going to do is we have to, of course, import our libraries. So we say import libraries, import libraries. Then we can go and actually make this a markdown, right? Can make it bigger, then we can simply run this. Now, the first library we want to import is, let's import pandas as PD. Then we say import numpy as NP. Then we say import tbon as SNS. Then we say import missing as MSNO. Then we can say import matplotlib as PLT. Or we can say that's same from matplotlib, I think, from matplotlib, import pyplot as PLT. Then we can say import warnings. So this is to ignore all warnings. Import warnings, and we can say warnings dot filter warnings. Warnings dot filter warnings. Then we say ignore. Right? Then let's go ahead and run this. So the first thing we have to do is import our data set. And to do that, we just say df equals to pd.read underscore csv, and we say this should be equals to read. Then let's go ahead and copy the parts of our data. So we just right click and say copy as parts. Then let's go ahead and paste this, and let's go ahead and run this. Okay, I think we are having a Unicode error. Okay, so to resolve this, we can just simply say encoding. This should be equals to Latin 1. I think this should be able to solve that issue we are having. Then let's go ahead to run this again. So we have successfully loaded our data set to our environment. Now the next thing we have to do is let's go over to say data investigation. Okay, so let's turn this to a markdown and let's run this. Now, data investigation, let's say when we are doing our data investigation, we are actually trying to know more about our data. Now, let's say the first thing we want to do is we want to look at the shape of the data, shape of data set, right? Now, to do that, we can simply say df.shape, df.shape. So let's write. So df.shape. So this gives us the shape of our data. So from this, we are going to see we have about 9,800 rows and 18 columns. So let's say the first head, the first five rows of our data, the first five rows of data set. So to do that, we say df.head. So let's run that. So as you can see, this is the first five rows of our data set. So as you can see, we have the row ID, we have the order ID, we have the order date, ship dates, ship mode, we have the customer ID, the customer name, segment, country, city, postal code. Then we also have our region, product ID, category, subcategory, product name, and sales, right? Now, let's say we also want to check let's get more info on our data, more info on data set. Now, let's say that should be df.info. So let's go ahead and run this. Now, this gives us more information on our data set. So from here, you can see that we have 9,800 rows and we have 18 columns. Now, these are our columns, okay? Now, this tells us if we have null values or missing values or not. Then this is actually the type of our data set, right? Now, when we go ahead and analyze this information on our data, we can see that, remember, we say that we have a total of 9,800 entries or 9,800 rows. Now, when you look at this, any column that is not up to 9,800 rows, which it simply means we are having missing values there, right? It simply means we are having missing values there. So if we are actually judging by that, you see that we have missing values here, okay? I think we have just one missing values, right? But we cannot just decide. We will still investigate this further. Now this tells us our data type. So integer object, which is categorical, then we have our floats, then we have our objects and our floats. Okay. So we have to go ahead to verify this, okay, later, much later. So let's just move ahead. Now let's say we want to get descriptive statistics of our data. Descriptive statistics. Now to do that, we say df.describe, right? Thing. Describe. Then let's go ahead and run this. Now this gives us statistical information on our data. As you can see, we can see the count of each row. Then we can see, and remember that when we are looking for the statistical information of our data, we are simply working with our numerical columns, right? We are simply working with our numerical columns. Now this gives us the count of our data for our numerical columns. Now this is our mean for each column. Now our standard deviation, then this is mean, our minimum value, then this is our mean, right? And this is our max value. Now let's go ahead. Now the next thing we have to look for, let's say we want to see our missing values, right? Let's say we want to see our missing values. So we can say df.itsnor.sum. Okay, df.itsnor.sum. Now let's go ahead and run this. Now when we go ahead and run this, you see that we have our missing value. We have missing values in our postal code, about 11 missing values, right, in our postal code, right? Let's say we want to go ahead and check how many columns we have. Check columns, okay, for white spaces, for white spaces. So to do this, we can say df.columns, okay. So let's go ahead and run this. Now this gives us our columns, right? Now you can actually investigate to see if there are white spaces, okay, between our columns names, okay. So we can check if there are white spaces, but from what I am seeing here, we do not have any white spaces. Okay, so that is looking okay to me. Now, the next thing we have to do, of course, let's go over to our data cleaning. Our data cleaning. So we just turn this to a markdown and let's run this, right? Now, the first thing, well, before we go, let me first call our, let's say, df.head, right? Then let's run this. Okay. Now this is our data set. This is what our data set looks like. So the next thing we are going to do is I want us to go ahead and drop our row ID on our poster code because these are not actually important for our analysis. Okay, so we are going to go ahead and drop these columns. But before then, I want to limit this to 2 so we can simply see the columns we want to drop when writing our code, right? Now to drop the columns, so thing we have to do is we say df is equals to df dot drop. Okay. So we say columns should be equals to, so let's say this should be equals to our row ID, row underscore ID, row underscore ID, right? And this should be the next column we want to drop is our poster ID. So we say poster underscore code, poster code. Then we can simply close this, right? Then we say axis should be equals to 1. Then we can simply close this. So let's go ahead and run this. Then let's go ahead and confirm what we did, confirm dropped columns, confirm dropped columns. Now to do that, we say df should be df dot head. Okay, so we are looking for the 2 first rows. Then as you can see, we have successfully dropped our poster code and our row ID, right? Now the next thing we have to do is I want us to go ahead and work on our missing values. So I want us to check missing values, right? Now to do that, we say df dot is null dot sum. So df dot is null dot sum. Okay. So let's go ahead and run that. And run that. As you can see, we have no missing values. Okay. But remember that up here we had a missing value in our poster code, a missing value of about 11. But because of we dropped our poster code, now we have no missing value. Okay, which is good. Now we can simply go ahead to visualize the pattern of missingness. Visualize the pattern of missingness. When we do this using our missing no, okay. Now when you look up here, you will see that we imported our missing no. Okay, so missing no is actually used to visualize the pattern of missingness in our data set. Now to do that, we say since we have already imported missing no, to do that we say df dot bar, okay, dot msno, okay. So let's go ahead and run this. Right, so that should be msno dot bar, okay. Then this should be df. Now let's go ahead and run this and see. So we wait for that to load up, okay. Now this shows the pattern of missingness. As you can see that we actually have no missing values. Remember we have 9,800 rows, okay. So as you can see from here, we have no missing values. Now, had it been we have missing values, you will see that some of those bar will be just low or below. And you will see that we have maybe a total of 9,700 instead of 9,800 rows. So we have no missing values. So now the next thing I want us to do after showing the pattern of missingness is I want us to actually get more info on our data so we can actually look at our data type properly. So let's say info on data. So let's say info on data sets, right? Then we say df.info. Okay. So let's go ahead and run that. Now let's go ahead and analyze this properly. But before then, I also want us to do df.head. Okay. So let's limit to 2 and let's run this too. Okay. So we can actually see the columns. Now let's go ahead and analyze our data types properly. Now, when you look at this other ID is given as an object. Well, this is correct because as you can see, the other ID, it has a letter, it has two letters before the number. So this is actually correct. Now, let's go ahead to look at the other date. The other date is giving us as object, which is incorrect. So we have to change this to date time. The same thing as a shipping date. Now let's look at the shipping mode. The shipping mode is giving us as an object, which is correct because when you see there, you see that they are all string. Now let's go ahead and confirm the customer ID. The customer ID is also correct. The customer name, of course, also correct, an object. The segment is also correct, an object. The country is also correct, an object. The state is also correct, an object. The region is also correct, an object. The product ID, let's look at the product ID, that is also correct, an object. Then the category is also correct, an object. The subcategory is also correct, an object. Then the product name, that is also correct, an object. Then sales float. Now let's confirm if sales is float. Okay, sales is float, which is also correct. Okay. Now from this, what we actually have to change, the data types we actually have to change is the order date and the ship date. And we have to change them to the date time data type. Now let's go ahead and work on that. So we say changing date, date columns to their appropriate data type. So to change the data type for our order date and our ship date, we can simply say DF. Now let's say we are working for the order underscore date. Okay. Now this should be equals to PD dot to underscore date time. Okay. Underscore date time. Now this should be equals to DF. What are we working with? Order dates, right? Order underscore dates. Now we have to close this and close this. Okay. Now we can simply do the same for our ship date. So we can simply copy this and let's paste this here. And we simply change this to ship date. Okay. So we simply change this to dates, ship dates. Okay, now let's go ahead and run this. So this is now a format issue. So to actually resolve that format in issue, we can simply come here and say equals to format should be equals to month. Okay, so should be equals to date. Then we say month. Then we say year, right? So that should be a string. So yes. Now we can simply come over here and simply copy this and paste here. Okay, so we can simply copy and paste here. Now let's go ahead and run this again. Okay, now that way we have specified the formats and we have successfully changed that. Now let's look at confirming results. Confirming results. Now this should be equals to df dot info. Okay, because we are trying to confirm the results of what we have done. So when we run this, as you can see, we have successfully changed it to our date time. Now, the next thing I want us to do is I want us to go ahead and extract the numerical and categorical columns. Now, let's say we are trying to extract the numerical columns. Okay, the numerical columns. Now to do that, let's call the numerical columns num underscore codes. Okay. Now let's say num underscore codes is equals to df. So let's say this should be equals to df dot select. Okay, underscore the type. Okay. Then include equals to. So we are trying to include the floats. Okay. No, I think we should have this there. Include equals to floats. Sorry. Let's say int then float. Okay. Now let's go ahead and run this and see what happens. Select underscore the types. Okay. Let's try this again. Now let's go ahead and check for results. So check results. So check results. Now this should be num underscore cos. Now let's go ahead and run this. Now let's go ahead and confirm that. So from our confirmation, we see that that is correct because cells is the only numerical column we actually have here, right? Cells is the only numerical column we have here, okay? Now, the next thing I want us to do is I still want us to go ahead and let's go ahead and extract our categorical columns. So extracting categorical columns. Okay. Now to do that, let's say cat underscore cos. This should be equals to df dot select. Okay, underscore dot types. Right. Now this should be equals to, let's say, include. So we are going to be including our objects. Okay, our objects and also our category, right? Now let's go ahead and close this and let's go ahead and run this. So they say include is not defined, so this should be include is equals to, right? So let's go ahead and run this again. Now let's check results. Okay, to do that, we simply say, let's just say cat underscore cos, right? Now let's run that. So as you can see, it's brought out all our categorical columns. Okay. So these are our categorical columns. All right. These are our categorical columns. Okay. Now, the next thing I want us to do is I want us to go ahead and do what I call data validation. Okay. Data validation. Now, to do that, I want us to go ahead and say parts underscore cos. Okay, dot value underscore count, right? Now let's go ahead and run this. So I want us to investigate all this properly. Okay, now for this, I want us to do something. I want us to look at this category properly. So for the category, I want us to do part underscore cos, then dot unique. Okay, now let's go ahead and run this. So dot unique. Okay, no. So we are supposed to do cat underscore cos. Then what are we looking at? We are looking at the category, right? We're looking at the category. So category, right? So let's just come down here and let's just say category, right? Let's just say category and let's just say dot unique. Okay. So let's go ahead and run this. Now we can see the unique categories we actually have. So we have the furniture, we have the office, we have the technology. So I want us to also do the same for cat underscore cos, right? I want us to do the same for, let's do the same for subcategory. So let's do the same for subcategory. So subcategory, right? Let's do dot value underscore count. Okay. Now let's go ahead and run this. Okay, so this is what we have. The copiers, machine supplies, partners, and furnishers, phone storage, and the rest of them. So these are the subcategories we have. Then I want us to also look at the products. So let's say cat underscore codes. Then let's say cat underscore codes. Then let's say we want to look for products. Right, product dots. Let's say unique values in products. So let's go ahead and run this. So they said products. Okay. So let's look at. Okay, so I think that's product name, not product. So we say underscore product name, underscore product name. So we run this. Now this gives us the product names we actually have, right? Now let's also do our data validation, data validation for numerical columns. Okay, numerical columns, right? So for this we have num underscore pose. So I think what we have is we're working with cells, right? Then we say dot value. Let me just say dot. Okay, let me just say dot value underscore count. Okay, dot value underscore count. Right. Now let's go ahead and run this. So that should be value, not values. Value underscore count. Now when we go ahead and run this, so you see our cells. Okay, so mostly we do this to check for negative values. Okay, to check if we have any negative values or all. So you see this is actually our cells, right? So now we can state that we have successfully done our data cleaning. Now the next thing we have to go over to, let's go over to our exploratory data analysis, which is the main reason for this lecture. Exploratory data analysis. Okay, now let's go over to make this a markdown, and let's go over to run this. Now this is our exploratory data analysis. Now if you remember in our first in the first part of this lecture, our theoretical part, we said that we have three types of EDA, which we said we have our univariate, bivariate, and multivariate. Now we are going to be taking each of these types of EDA one after the other. Now we are going to be working with our univariate analysis, okay, univariate EDA, right? Now let's just turn this to a markdown. Let's just turn it to a markdown and let's run this, okay? Now I want us to show, I want us to do our, but before we move ahead, the next thing I want us to do is I want us to combine, okay? I want us to combine our numerical and categorical columns. So now to actually combine our numerical and categorical columns, we say let's call this df1, right? So let's say df1 is equals to num underscore codes, okay, dot concat. So we can use concat. Then what are we concatenating? That should be num cat underscore codes, cat underscore codes. Now let's go ahead and run this. So it says data frame object has no attribute concat. So I think we are actually making a mistake here. So I think this has to be pd.concat, right? pd.concat. Then what are we trying to concatenate? We are trying to concatenate the num pose, right? Num underscore pose, right? And cats underscore pose. Now let's go ahead and run this. Okay, so it says concat takes. Okay, so it says concat takes one positioner. Okay, so here we have to put this in a list, right? So put this in a list. Now let's go ahead and run that. Okay, now let's check for results. Check for results, right? So let's go ahead and print the f1 dot head. So let's go ahead and run this. Okay, so from this now you see that all our categorical columns is actually giving us NIN. So to fix this, let's say as this is equals to 1, right? And let's go ahead and run or so let's run our cells. Okay, now that actually makes more sense, right? So since we have successfully joined the two data frames together, which is the numerical and the categorical data frames together, we can now go ahead to perform our exploratory data analysis. Okay. And remember, like I mentioned, during the first part of this tutorial, I mentioned that we actually have three types of EDA, which I said we have our univariate analysis, bivariate analysis, and multivariate analysis. So at this point, we are going to be starting with our univariate EDA. So we just make this a markdown and let's run this, right? Now, remember that I mentioned that when we are talking about univariate, we are simply trying to understand a single column, okay? We are trying to understand a single column. We are trying to know what is actually happening in a single column. So we are just trying to understand the structure and patterns and everything going on in a single column, right? Now, the first thing I want us to do is I want us to work with our categorical columns. Okay. Now we say cat underscore calls, right? Cat underscore calls dot, let's say info, right? Then let's go ahead and run this. Now this is actually our categorical columns, right? This is our these are our categorical columns. Now as you can see, we have the order date, we have the ship mode, we have the customer ID, and the rest of them, right? Now there's something I want us to do. I will actually want us to drop some columns, okay? So I will actually want us to drop the order ID. I also want us to drop the customer ID. Now, when you actually look at this information, you will see that we have a total of 9,000 entries, 9,800 entries, and 13 columns, okay? Now, basically, our order ID, there is actually nothing we are actually using this our order ID for. There is no analysis we are going to be using this order ID for. There is no analysis we are going to be using this customer ID for. And so what we are going to do is we are going to drop these particular columns. Okay. So we are going to drop those particular columns. Okay. So whether we drop them or not, it doesn't actually make any difference. Okay. Since we are going to be working with columns, we are going to be working with each data frame, okay? But for this, what I want us to do is this. I want us to go ahead and drop these rules, right? I want us to go ahead and drop these columns, okay? Right before we concatenated our numerical and categorical columns, right? So, so over here, okay? So right before we concatenated this, so I want us to go ahead and drop this particular columns. So let's say dropping our order ID, dropping our order ID and dropping our customer ID also. Let's say cats underscore codes, okay, is equals to cats underscore codes dot drop, okay, dot drop columns should be equals to let's call this order ID, okay, order underscore ID, and the next we are dropping is customer underscore ID, sorry. So let's say customer ID. Yes, we also want us to drop customer ID, okay, customer underscore ID. And the next thing I want us to do is I want us to also drop our let's drop our product ID also. So all IDs, we are actually dropping all IDs, product ID. Okay. Then we can say in place equals to sorry. So we can say in no axis equals to one. Then let's go ahead and run this. So let's say we are trying to go ahead and confirm that. Let's say confirming results. Okay, confirming results. So this should be cat underscore course, right? Let's just call it cat underscore course. So okay, so as you can see, we have successfully dropped that. Okay, so we just have to go ahead and run all cells, right? So we go ahead and run all cells. Okay, so after running all cells, so after concatenating, you can see that now we simply do not have our IDs over there again, right? Now, when we go ahead to also check for our cat underscore codes, you see that we just have our ship mode, our customer name, our segment, our country, our city, our state, the region, the category, and the subcategory, and the product name. Okay. Now, one thing I want us to do is I want us to check the unique values in product name. So let's say cat underscore codes is equals to cat underscore codes is equals to, or let's say cat underscore codes. Then we say product name, right? Product underscore name. Okay. Let's say dot unique. Okay. Dot unique. So we say product order that same dot unique. So let's run this. So as you can see, okay, I think we have done this before. We see the unique product names we actually have over there, right? The unique product name we actually have over there. Now let's go ahead to start working on our univariate analysis, right? Now we can simply actually create a subplot, okay? So instead of going ahead to actually visualize this one after the other, visualizing this one after the other, we can simply actually create a subplot that actually shows all these columns, okay? That shows all these columns in one visual independently, okay? Now, because of, I also want us to learn how to actually tell a story using our data sets, okay? To tell a story using our data sets, I will not actually go ahead to start creating a subplot for this. Instead, I'm going to be taking 3 or 4 columns, okay, from these columns we have here to visualize them so we can see how we can actually write a story and actually give business recommendations using our data. Now, let's start over. So, let's say, for example, we want to create a bar plot or a bar chart, sorry, for let's say we want to create a bar chart for our ship mode. So we are actually trying to create a bar chart for ship mode. Okay, ship mode. Now to do that, what we have to do is we simply have to say count. Okay, so we are trying to say the count of ship mode, right? Now the count of ship mode should be equals to, so this should be equals to counts underscore codes, right? Now we are looking to count our ship mode, right? Ship underscore mode. Okay. Now we can simply say dot value underscore count, dot value underscore count. Okay. Now we can simply say the next thing we can simply say, okay, for here, let's call this count of ship mode, count of ship mode. Okay. Now for this, let's say setting fig size. So setting figure size. So we are trying to set the size of our bar chart, right? So this should be equal to plt dot figure, right? Plt dot figure. So this should be equals to fixed size. Okay, should be equals to 12, let's say 12 by, or let's say 10 by 8. Okay, 10 by 8, right? Then we can simply close this, right? Now, the next thing we have to do is go ahead and plot our bar charts, okay? But before we do that, we have to say ship. Okay, so we have to say count underscore ship mode. So we have to say dot plot. Okay, so what are we trying to plot? We are trying to plot a bar chart. So we say kind should be equals to bar, right? Kind should be equals to bar. Then we can simply set a color. So let's say color is equals to sky blue. Okay, color is equals to sky blue. Okay, then sky blue. Then we can simply say edge color. Let's say edge color should be equals to blue, or let's use black. Edge color is equals to black. Okay, so edge color is equals to black. Then we can go ahead and close this. So the next thing we can simply go ahead to do is plot the bar chart or go ahead to customize bar charts. Okay. So let's say customize bar charts, right? Now to customize our bar charts, we add our title on all. So we say plt dot title. So let's call this count of bar count of ship mode, right? Count of ship mode. Let's say the next thing we have to do is plt dot x label. Okay, so plt dot x label. Let's call this our x label should be our ship mode. Okay, then plt dot y label. Our y label should be count of ship mode. So this should be sorry. So this should be count of ship mode. Okay, of ship mode, right? Now we can simply say plt.st. Okay, plt.st. Now let's call this rotation always equals to 45. Rotation always equals to 45. And let's say plt dot tight. Okay, so tight layout so our visual doesn't go all over the place. So the next thing we can do is to show our bar chart. To say plt dot show. So let's just go ahead and run this. Now, as you can see, this is the count of our ship mode, right? This is the count of our ship mode. So I want to actually make this a bit smaller so you can actually see the visual, right? Or I can simply decide to make this, instead of making this smaller, I can decide to make this visual a bit smaller. So I can just simply decide to make this 8 by 6, right? 8 by 6. Then let me run this. Okay, now this actually is looking smaller, right? Now, when you actually look at this particular visual, right, you can see that there is a lot of information we can actually draw from this particular visual. Now, this is what is called an example of a univariate analysis, right? A univariate exploratory data analysis. Why is it a univariate exploratory data analysis? This is actually because we are actually working with one column, which is our ship mode, and we are trying to draw more insights or trying to understand the structure, the pattern in this particular column. Now, when you look at this particular ship mode, what can you tell? You can simply say that, you can simply tell that this complaint actually operates using four different ship modes, right? Now, they operate using the standard class, second class, first class, and same day ship mode, right? Now, when you actually look at all this, at this diagram perfectly, where you see that they have four different kinds of shipping mode for their customers. Now, when you look at this, you find out that the standard shipping mode has the highest counts, which means that customers often use the standard shipping mode compared to the second class, first class, and same day. Of course, what you have to understand is that the standard class, the let's just say we can simply go ahead and say this is actually the economic class, okay, the economic class shipping mode. Now, of course, one thing you will understand is that in a company the standard shipping mode will actually be less expensive compared to the second class, compared to the first class, and compared to the same day. Now, when you actually look at this, okay, you can simply tell that okay, customers often go with the standard class shipping mode, maybe because it is actually less expensive. Okay, it is less expensive compared to the other types of shipping mode. And another thing we can actually say is that most customers go with the standard class shipping mode. Maybe it could actually be like the standard class shipping mode delivery timeline is not very long, okay, or the difference between the standard class shipping timeline is not it doesn't have much difference, okay, compared to the other classes. Let's say, for example, the standard class shipping mode can actually be maybe 10 to 5 days, okay, or 5 to 10 days, while the second class shipping mode can be maybe, let's say, it can be maybe 8 to 10 days, okay. Now, most customers may feel like, okay, there's no more difference. Instead of spending an extra dollar just because of a 3 days difference, why can't I just wait? okay, and save my money and wait and use the standard class. Okay, so these are things we can actually draw, insights we can actually draw from this data. Now, when you look at this same day, you can simply see that most customers do not actually go with this same day delivery. So it is actually easy to say that most of the orders that this company or this business gets, okay, are not urgent orders, right? They are not urgent orders. They hardly get urgent orders where the customers will want to actually use their items or get their delivery the same day. Okay. Now, also, when you look at this, you see that the second class delivery is actually higher than the first class delivery. Of course, like I mentioned, the prices would be definitely different. It's just like let's use an airline for example, when we have the economic flares, the business class, and the rest of them. So we can actually apply the same idea here, right here. Okay. Now, as you can see, that the second class customers actually use the second class model or the second class shipping mode compared to the first class shipping mode. Now, using this insight we have actually done from this, we can actually write a short story about this, okay? And we can also give business recommendations on this, right? So let's go ahead and do that. From the analysis, right? The company operates on three different mode of shipping. Okay, three different mode of shipping, which are the standard class, second class, second class, then first class, first class, and same day. Okay, so I think this should be four, right? Not three, four, and same day, right? So the standard class. Okay, I think I need to make this a markdown now. Make this a markdown. Okay. So of the standard class mode of shipping has the highest count, has the highest count, followed followed by the second followed by the second class with the same day with the same day shipping mode being the lowest, being the lowest, right? Now we can simply say from this analysis, we can conclude that customers prefer using the standard class shipping mode compared to the other shipping mode. Now, if we actually working with this particular company and we understand the reason why these customers like using the standard class shipping mode. Now, let's say we are working with this company and we know that okay, the reason why why customers like using the standard class shipping mode is actually because of it is actually the cheapest, right? It is actually the cheapest. So we can simply say that the the reason okay for this is because the standard class offers the standard class shipping mode offers a cheaper rate, and also our product are not are not Okay, let's just say offer the standard class a cheaper rate, right? Sorry, this is because the standard class shipping mode offers a cheaper rate compared to the other shipping modes. Okay, now we can simply say business recommendation. Business recommendation, right? Now, number one business recommendation could be further analysis. Further analysis should be made on why customers prefer the standard class shipping mode. Okay, why customers prefer the standard shipping mode. Okay, no, I think because we already know why the customers prefer the standard shipping mode. So saying further analysis should be made on why customers prefer the standard shipping mode doesn't really make sense. So I want us to write this business recommendation just like we are working in this company, right? Now I think number one recommendation should be okay, the prices of the other mode of shipping should be reviewed, okay, to attract more customers, should be to reviewed to attract more customers, right? To attract more customers, okay. Then we can also say promo programs. Promo programs can also be used to entice customers that make use of shipping mode, that make use, sorry, that makes use of shipping mode aside aside the standard class. Okay. So So we can simply say, yeah, we can now say further analysis should be made, should be made to understand the difference, okay, between the delivery time for all shipping modes, okay, for all shipping modes, okay. So that way we can determine that customers actually get the value for the money, so we get the value for their money when they opt for other shipping modes, okay, aside from aside from the standard shipping, okay. Now, which other recommendations can we give here? Which other recommendations can we give here? To also persuade customers from, okay, okay, we can simply say to also, right, I agree with it. So these are the business recommendations and the story we can actually tell from this particular univariate analysis, okay, from those particular univariate analysis. Now let's go over to the next. So we go ahead and run this. Okay. Now let's look at this data again. Now let's say we want to go ahead and look at the segment. Okay. Now this is also under univariate analysis. We just want to go ahead and look at just the segments alone. Okay. Now what do we do? Instead of going over to start writing our code from the beginning, we can simply copy this, right? We can simply copy this. Then we can simply come over here and paste this. Okay. Now we can simply save for segments. Okay, for segments, we are also going to be using a bar chart. So we can simply call this count of segments. Okay, count of segments. Okay, now this should be called segments. Okay, now we can simply say, so let's just copy this here right now, and let's come over here and let's highlight this and paste. Okay, so we highlight this and paste, right? Then we can leave color the same. Okay, we can leave color the same instead of having different colors of visuals. So it's advisable to leave color the same or limit colors to maybe two, one or two. Yes. Now the next thing we can actually do is let's go. Title should be count of segments. Okay, count of segments, right? Then this should be segments. Okay, this should be segments. Okay, now this should be count of so this should be count of segments. Okay, count of segment. Okay, or let me just call this. Let me just okay, yeah, let's say count of segments, right? Oh no. So let's just say count of segments, right? Count of segments. Okay. Now we leave every other thing the same. So let's go ahead and run this and see what happens. Now, when we go ahead and run this, as you can see, this is actually what we got. Okay. But now let's actually make this visual a bit smaller. Now let's make this 7 by 5. Okay. So let's make this 7 by 5. Now let's go ahead and run this. Now let me see what we have there. Okay, now this is giving us a 7 by 5, which is quite okay for me. Now, as you can see from this, we can actually say we have three different segments where we have the consumer, the corporate, and the home office, right? Now, when you look at this visual, this bar chart, you can simply say that the consumer actually has the highest count. Okay. Now, from this diagram, we can actually deduce that maybe this company actually has three segments. Okay, three segments of consumers. Okay, three segments of consumers, or let's just say these customers have three segments. Okay, they actually distribute to, right, where they have the consumers, which are the final consumers. Okay, maybe they produce and give directly to and sell directly to retailers. Okay, probably this company has a walk-in shop. Okay, they have a walk-in store where customers just come in and patronize them. Okay, now this is the aspects where consumer can come in. Now, I'm actually trying to create a scenario, okay, of what could be the possible case for this company, okay. Now, they actually have another segment where they deal on corporate companies alone. Okay, maybe corporate companies, maybe they render their services to corporate companies, maybe deliver their products to corporate offices. Now, they actually have another segment, home office, okay, where they deliver to people that actually work from home, okay, maybe stay at home wives, okay, stay at home, people that work from home, freelancers, remote workers, and the rest of them. Now, let's say these are the three segments. Now, from this explanation, one thing you will understand is that the consumer segment actually has the highest count. Okay, the consumer segment actually have the highest count. Now, it is actually fair to say that this particular segment, okay, this particular segment is, or sorry, it's even now, it's totally okay to say that this particular company gets the most of their customers through consumers, their final consumers, okay, compared to corporate and home office. So it is okay to say that the highest consumer of this particular company's products are individuals, okay, based on my explanation. Now, based on this visual, we can actually go ahead to actually write a story, okay. Sorry if I'm being too fast. Now, based on this, we can actually go ahead to write a story. Now, let's go ahead and do that. Now, let's say writing a story, writing a story and giving business recommendation, giving business recommendation. Okay. Now we can turn this to a markdown and let's run this. So for this, we can simply write a story that says from this analysis, okay. Oh no, it's not that. Let's say this analysis shows that shows that the consumer segment has the highest number has the highest number of sales orders, okay, followed followed by the corporate followed by the corporate followed by the corporate, then then the home office, okay, the home office, right? Okay. Now we can also say this indicates, sorry, let me make this a markdown. We can also say this indicates that the business serves a let's say a predominantly consumer oriented customer base, right? Customer base with most of their transactions coming from business clients, right? Coming from business clients. So I think this is a story we can actually write here. Okay. So yes. Now for recommendation, okay, so we can simply say recommendations. Or let's just make this, so let's just say business recommendations, right? Business recommendations. Now we can simply say one, okay? We can simply say focus focus on consumer. Okay, no, instead of us to give it a headline, we can simply say since the most orders since the most orders come from consumers, okay, we should ensure the buying experience is seamless, okay, is seamless, right? Is seamless, okay. So we can also say we should optimize product availability, or let's say product availability should be optimized. I don't know why my system is lagging. Product product availability should be optimized, okay, including pricing, including pricing and customer support. Okay. Now another thing we can say is We can simply say, okay, the lower volume of the other segments suggests a room for growth. Okay, suggests a room for growth, right? We should consider targeted outreach, okay, or tailored offerings, right? Or tailored offerings to increase their engagement, to increase their engage. We can simply say, okay, let's just say segment-based marketing. Sorry, segment-based marketing should also be considered. Okay, I think this is it. So we can go ahead and run this. Okay, now this makes sense. Now, so we have actually been able to actually look at two examples, okay, from univariate analysis, okay. So there are more examples we can look at. We can actually look at the count of region, we can look at category, and a lot of other things we can actually look at here, country and all, okay. But like I said, we are going to be limiting it to just two examples per type. But like I said, we are going to be limiting it to just two examples for each type of. And but like I said, we are just going to be limiting it to two examples each. Now let's move ahead. Let's go over to bivariant analysis, bivariant exploratory data analysis. Okay, data analysis. Now, during the phase one of this tutorial, like the name implies, when we are working on bivariate, we are trying to actually look at two different data, okay, two different columns. We are trying to know the relationship existing between two different columns. Now, for this particular data, now for this particular EDA, we are going to be working with our combined data frame. Okay, so let's go over to check for our combined data frame. Now our combined data frame is the F1. Okay, so let's go over to code the F1 and let's run this. Now this is our df1. Okay, so we can simply say df1 dot head, and let's say limit it to just two rows. So we can run this, right? So sorry, this should be dot head. Okay, so we can run this. So now we can see that this is our combined data frame where we have our categorical and numerical columns. Okay. Now we can go ahead to start performing our bivariant analysis. But before we go ahead, I want us to do df1 dot columns. Okay. So oh no, let's do df1 dot info. So we see what we are actually working with. So we see the columns we are actually working with. So let's go ahead and run this. Now, when we run this, you see we have our cells. So the cells is basically the only numerical data or the numerical column we actually have. Okay. So the first thing I want us to do is I want us to look at the segments. Okay, let's look at segments by cells. Okay, so we want to know the segment with the highest cells. For this, we can simply say cells segment. Okay, sorry, cell segment. Cell segment should be equals to df1 dot go by equals to df1 dot go by. Okay, then segments, okay, then cells, okay, then we can say dot sum So let's say dot reset index. Okay, is it dot reset? Yeah, dot reset underscore index, I guess. So that should be okay. So here, let's just call here grouping. Let's just call here grouping cells by segments. Okay. Now the next thing we have to do is figure of bar charts. So this should be plt dot figure. Okay. Plt dot figure. So we say fixed size. Fixed size should be sorry. Fixed size should be equals to fixed size should be equals to, let's say, 7 by 6. Okay, 7 by 6. So plt, okay, no, this should go up. So plt dot bar, plt dot bar. So this should be segment underscore, this should be cells underscore segment, cells underscore segments. Okay, so this is a segment. Okay, then segments underscore cells, then this should say cells, should say cells. Okay, then color, let's leave color as sky blue, right? Sky blue. Okay, I think that works. Now let's set our title. So we say plt dot title. Okay, plt dot title. So let's call this total sales, total sales by segment. Okay. Then the next thing we have to do is, let's say plt dot x label. Okay, plt dot x label. So we can call this segment, right? Plt. Okay, sorry. Let's call this segment. Okay. So let's say plt dot y label. So let's call this total sales. So let's call this total sales. Then let's say plt dot type underscore layout. Then let's say plt dot show to show this. So let's go ahead and run this. The segment name segment dot cells not defined. Segment underscore cells not defined. So where do we have segment underscore cells, please? Right, okay, cells segment. So cells segments. Now let's go ahead and run that again. Now this works. So now from here, we can also see that the customer, right? We can also see that from here that the consumer actually has the highest sales, okay, compared to the corporate segment and the home office segment. Now we can actually write a story for that and also give business recommendations. So now when you actually look at this, right, you find out that we actually did likely something similar to this when we are working on the count of segments. Okay. Now, when you look at this story we wrote, you can see that, and this business recommendation we wrote, you can see that it can actually surface here also, right? It can actually surface here also, because as you can see that the consumer segment actually has the highest total sales, right? The consumer segment has the highest total sales, followed by the corporate segment and the home office segment. So the same business recommendation we gave here and the same story we gave here can also be applicable here. Okay. Now, instead of us to go ahead to start taking time to write the same story, okay, or to write something similar or in a different ways for this, we can just move ahead to the second example. Now, for the second example, I want us to look at the region. Okay, I want us to look at the region. Now, for that, I want us to first of all do the F1. Okay, then I want us to see region. Okay, region, so region dot unique. So let's look at the unique values in region. Now, as you can see, we have the southwest, central, east. Now, I want us to look at the region with the highest cells. Okay. Now, I want us to look at the region with the highest cells. Now, to do that, we can simply say region with the highest cells. Okay. So we can simply paste this here, right? We can simply paste this here. Then we can simply say region. Okay, so we can simply say region, right? Then we can simply say region. Okay. Then we can simply say, let's simply copy this. Okay, let's simply copy this. Then here we can simply paste this. Then we can simply paste this here, right? Then here we can simply change it to say region. So let's just change it to say region. Okay. Then here can stay sales. Okay, total sales by, let's say total sales by region, of course. So total sales by region. Okay. Then here we can simply say region, region. Okay. Then we can simply run this. Now, when we run this, you can see what we are seeing here, right? You can see this. Now, we can see that the region with the highest sales is actually the West. So for this now, we can actually write a story and give recommendations. Now, for writing a story for the analysis, we can simply say from the analysis. First, let's turn this to a markdown, of course, markdown. All right. Now, we can simply say from the analysis, okay, the from the analysis, we can see that the west region has the highest. Okay, let's confirm that. Is it the west region though? Yeah, the west region. Yeah, we can see that the west region has the highest sales. Then followed by the east. Okay, south, central, east, central, and south region. Okay. Okay. So for recommendations, we can simply say business. Let's make this smaller. So we can simply say business recommendations. Recommendations. Okay. So we can simply say um campaign. Okay, or advertising. Okay. Or let's say A/B testing. A/B testing campaign. Okay, should be used, okay, for other regions to determine, okay, let's say for underperforming regions to determine which ad campaign, okay, or which ad campaign performs better in improving sales. Then we can also say the marketing strategy used for the west region should be studied and use to and use for on the performing region or the performing regions. Okay. So we can say further analysis can be carried out. Further analysis can be carried out, can be carried out, can be carried out to determine the exact reason for the cells the exact reason for cells difference, okay, across regions. Then we can say promo activities, okay, or promo should be given to in regions, okay, like the south region. Let's say promo in form of discounts, okay, discount of free products should be given to regions like the south to see if it can improve sales. Okay. Now I think this is actually what we can actually do. Okay, these are the business recommendations we can actually give. Okay, so let's go ahead and run this. Now, the next thing we have to go to is we have to go to our multivariate analysis. Multivariate analysis. Okay, now let's turn this to a markdown and let's run this. Now for multivariate analysis, remember when we were talking about multivariate analysis, I told you that multivariate analysis is a type of exploratory data analysis where we actually work with three or more columns, okay, where we try to know the interaction between three or more columns, okay. Now for this our particular data, okay, there are various exploratory multivariate exploratory data analysis we can actually carry out. But the first I would like us to look at is the sales by segment and shipping mode across region. Okay, so let's look at sales by segment, okay, and shipping mode across regions. So to do this, we actually have to say, let's call this group is equals to, we are working with the F1, remember? So this should be dot group by, right? Dot group by. So this should be, what are we working with? We are working with region. Okay, we are working with region, right? So this should be a string. So we are working with region. Then we are also working with what again? We are working with segment, right? We're working with segments. Then we're also working with what again? We are working with shipping mode, right? Shipping mode. So we are working with ship underscore mode, right? Sorry, ship underscore mode. And we are also working with cells, right? So we are also working with cells. So this should be cells, okay? Cells, right? We are working with cells, okay? Now we need to look for the sum of cells. So we say cells dot sum, okay? Cells dot sum, okay? Then the next thing we have to do is, let's say dot resect underscore index, right? Underscore index. Now the next thing we have to do is we actually have to say group should be segment, right? Segment, okay, underscore ship mode, right? Then the next thing we have to say is this should be equals to groups, okay? Then this should be segments. Sorry, this should be segment, okay? Segment. Then this should be plus, let's say, an empty string, right? and this should be plus groups. Okay, plus group. Then this should be ship mode. Okay, ship underscore mode. Right. Now the next thing we have to do is so let's so the next thing is let's go ahead and create a pivot. So we say pivot underscore df, right? Now let's say this should be equals to grouped dot pivot, right? Dot pivot. So let's say index should be equals to region. Okay, let's choose region. Sorry, that should say region. Okay, then columns should be equals to, let's say, segment ship underscore mode. Sorry, underscore mode, right? The values should be equals to cells. Okay, value should be equal to our cells. Then, okay, the next thing we have to do is let's say pivot.df. Okay, dot plot. So we say kind is we are trying to plot a kind should be equals to bar, right? Kind should be equals to bar. Then we say stacked equals to false. Sorry, that should be equals to true, yes, because we are creating a stacked bar chart. Then fixed size. Let's say this should be equals to, let's call it sorry, six let's say 6 by 8, right? Then we say plt dot title. Okay, plt dot title. This should be, what should we call this? Right, let's call this cells by region. Okay, and ship mode, right? Ship mode. Okay. Then the next thing we have to do is we say plt dot label. No, we say y label first. So y label, this should say all cells, right? Then x label, plt dot x label Okay. So this should say region, right? This should say region. Then we say plt dot legend now to show us which column has. So we say title should be equals to segment ship, ship mode. Okay. Then we can say bb box. Okay. Then underscore to anchor. This should be equal to 1.05 by 1. Okay, 1.05 by 1. Okay. So then this should be, so we say lock is equals to upper left. Then we can simply say plt dot type underscore layout. Then we can say plt dot show. Okay, so we have an error here, so we just have to remove this, right? Let's try running this again. That says segment upper left. Okay, they said it was never closed. So we just have to go ahead and close this. Now let's go ahead and run this again and see what happens. But wait for it to run. Then we have an error again. So segment underscore ship mode. So wait, let's go ahead and say df dot columns, df1 dot columns. So ship mode with segments, right? Segment ship mode. Okay, so this is what we have now, right? So using this, we can actually write the story. So let's go ahead and write a story. So we can simply say the west, okay, the west region, okay, the west region, okay, the west region, yeah, the west region leads, okay, all other regions, right, exceeding, okay, 700K, 700K, right, driven mainly by, driven mainly by, so let's look consumer standard. Okay, I think this is consumer standard. So driven mainly by consumer standard, right? And consumer standard, and let's check the consumer standard and corporate standard and corporate standard class, right? So let's make this a markdown. So let's say driven mainly by consumer. Let's just say consumer and, so let's just say consumer and corporates, okay, using the standard shipping class. So this is shipping class. So this is more explanatory, right? And we can simply say follows the east follows closely, right? The east follows closely, right? While the south follows closely. Sorry, okay. The east follows closely, while the south lags behind, significantly, significantly. Okay, okay. Now we can also say across, across, across all regions, the standard class shipping mode dominates. Shipping mode dominates, right? So this shows customers preference, okay, preference for affordability, over speed. So the same day the same day and first class contributes minimally, 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 which also shows an untapped growth potential. Okay, growth potential. So for business recommendation, okay, we can say premium shipping, premium shipping should be promoted through incentives and bundle offers. Okay, so we can also say weak demands should be investigated and targeted promotions should be introduced. We have come to the end of this tutorial. Okay, we have come to the end of this tutorial, and I hope that this tutorial have been helpful to actually help you know how to clean a data set, right? Perform EDA, write business recommendations, and tell a story from your visuals. Thank you so much for watching, and don't forget to hit the subscribe button, like, and share.